Red sky at night, shepherd's delight. Red sky in the morning, shepherd's warning. The weather plays a major role in determining if a bushfire will occur. In fact, weather affects everyone and everything on the planet. The amount and types of food we eat, the types of clothes we wear, and the buildings that we live in are all influenced by the weather.
When it comes to farming, sailing, aviation and lots of other industries, even things like concrete pouring are totally weather dependent. So having an idea of what is going to happen with the weather is very, very important.
Some weather law, like the red sky at night saying, are based on observations of the sky, clouds and the sea. Unfortunately, they are only valid in the locality where they originated. It was known that weather moves in patterns across the sky, but budding weather forecasters faced a major hurdle. They could not see over the horizon and did not know what weather was on the way. If observations could be made in more than one location, and that information could be collected quickly, it would help people to identify the moving patterns and hopefully to forecast the weather. With the invention of the telegraph in the 1830s, it became possible for weather reports to be collected in a variety of locations and communicated quickly to a central point. The first person to do this was an Englishman, Robert Fitzroy, who had sailed on the Beagle with Charles Darwin. Fitzroy set about establishing a storm warning service for sailors, with maps covering the British Isles and the northern coastline of France.
He had a great number of disadvantages compared with what we have today. He didn't understand the motions of the atmosphere. He didn't know the physics of it. He didn't have any observations from higher levels up through the atmosphere. He didn't have any satellites. He didn't have aeroplanes. So he was using purely surface observations. And consequently, his forecasts were on occasion incorrect.
The basic method used by Fitzroy is the same one used today and has 4 main steps. Firstly, observations of the atmosphere are taken accurately, frequently, and with as much detail as possible. Armidale is a picturesque country town in New England. The local observer is Peter Burr. At 9 o'clock each morning, he takes readings from this weather station. He measures the temperature, air pressure, humidity, evaporation, wind speed and wind direction, as well as the rainfall. He observes the cloud type and amount, the general weather conditions and the visibility. Here on Fort Denison, in the middle of Sydney Harbour, this automated weather station takes readings. An advantage of automatic weather stations is that as long as they have a power supply and a communications link, they give the Weather Bureau a constant reading of temperature, air pressure, humidity, wind direction and speed, as well as rainfall. This is especially useful for taking readings in remote or sparsely populated areas. Here at the airport, another automated weather station complemented by trained meteorological observers takes measurements. There's also a series of mobile weather stations flying overhead. Computers in aeroplanes flying through the atmosphere record weather information automatically. They also do a complete set of observations as they come into land, measuring wind speed, wind direction, turbulence, and the temperature from cruise level, all the way down to the ground. Four times a day, weather balloons are released at various points around the globe. As they go up through the atmosphere, they measure the wind direction and speed, the temperature, air pressure, and humidity. As they rise, they give a picture of the atmosphere at different altitudes. Ships at sea also observe the weather. A fleet of ships around the Australian coast usually do weather observations every 6 hours. They transmit their data to the Weather Bureau by radio or satellite. Ocean buoys measure the wind speed, the wind direction, the temperature, and drifting buoys also give information about currents as they float along. They send the data back to the Weather Bureau via satellite. Satellite images also convey important information to weather forecasters. By taking these observations all over the place at the same time, it's possible to get an instant snapshot of what the weather is like all the way around the world. Once the data has been collected, it must be forwarded to a central point, in this case the Bureau of Meteorology. There are a number of different ways of doing this. Most weather observers have a terminal attached to their telephone. They type in a coded message and send it to the Bureau of Meteorology along the telephone lines. The information is then sent out to regional offices or any office that needs it, where it is plotted onto charts.
Chart plotting used to be done by hand, and it's a laborious thing. We used to plot a chart that covered half the globe, and you'd start plotting it at 8:30 in the morning. It would be finished at 2:30 in the afternoon, so 6 hours went into plotting that chart. These days the computer does it in 5 minutes.
All of these observations plotted onto the chart represent what the weather was like when the observations were taken. Now the forecasters can begin their analysis. There are 3 major factors that affect the weather: the amount of heat received from the sun, the spinning of the earth, and the amount of water in the air, the humidity. With the help of satellite pictures, earlier weather charts and the observations themselves, the weather forecasters do an isobaric analysis first of all. Lines are drawn joining places of equal pressure. It's a lot like connecting the dots. These lines are called isobars. They allow the forecaster to see the location of high and low pressure systems. Then the fronts are drawn in. A front is the boundary between 2 air masses with markedly different characteristics. Fronts move through the atmosphere, and their timing can have a major impact on weather conditions. For example, if a cold front passes over a city at 4 o'clock on a summer's day, chances are there'll be a hot day ahead of the front, and when it arrives there is an increased chance of a thunderstorm, provided conditions are right. Should the front come through at 10 o'clock in the morning, it's only going to be a warm day and thunderstorms are less likely. A difference of 6 hours can result in a temperature variation of more than 10 degrees Celsius. This completed weather chart gives the forecaster a picture of what the weather was like when the observations were taken.
The winds.
From this, they draw prognoses, which are charts of how they think the weather will develop in the next 1 to 4 days. Forecasters are helped by the fact that the weather follows certain patterns. For example, surface winds always spiral outwards from the centre of high-pressure systems towards the centre of low-pressure systems. Although the pressure systems themselves are moving, forecasters learn to anticipate their most likely future movement. Computers do it slightly differently. They use numbers to predict the weather. The first person to try to develop a way of predicting the weather numerically was a British physicist, Lewis Fry Richardson. It took him a year to do the calculations to produce a forecast 24 hours ahead, and even then he was wrong. With the development of computers and their ability to do hundreds, then thousands, then millions and now billions of calculations per second, as well as refinements to Fry's mathematical model, numerical weather prediction has become a reality. Computers collect weather data from all over the world and assign a meteorological value to points on a grid system all the way around the globe at different levels through the atmosphere. Then, with reference to each point, they move everything on using Newton's laws of motion and the laws of thermodynamics to work out what's going to happen. This is how it works. The atmosphere is well described by 7 attributes, namely pressure, temperature, air density, water content, wind speed, wind direction, and vertical wind. Calculating these attributes at any location and time requires 7 equations. The equations are: the gas equation. This relates pressure to the density and temperature of the air. Newton's second law of motion. This law gives 3 equations. 2 deal with the horizontal wind speed and direction, and the third addresses vertical wind. The equation of continuity. This requires that all the air must be accounted for. The atmosphere is not allowed to gain or lose air. A moisture equation. This accounts for all the water in the atmosphere, noting that water can exist as ice, liquid drops or vapour, and that the atmosphere can gain moisture through evaporation or lose moisture through precipitation. A heat equation. This is the first law of thermodynamics, and in simple terms means that if heat is added to the atmosphere, its temperature will be raised, or it will expand, or a combination of these 2 alternatives will occur. Then the computers formulate prognostic charts from 1 to 8 days in advance. There are 6 different mathematical models that computers use to forecast the weather. Australia, Europe, Britain, Japan, and the United States all have their own way of solving these equations that is slightly different from the others. At the Bureau of Meteorology, they use all available computer models. If they're all predicting the same thing, then forecasters can be very confident about what is going to happen over the next few days. If they're markedly different, forecasters go with the model that they think is the most correct or choose an intermediate prediction. At the moment, the Bureau of Meteorology issues forecasts for 7 days in advance. They can't forecast further ahead than this because as you get away from the source of the observations, the accuracy of the forecasts decreases.
Now there comes a point where the accuracy of the forecast is no better than statistical forecasting or persistence forecasting. Now, persistence forecasting is very easy. You can do that anywhere, and it goes like this. If it's fine today, it'll be fine tomorrow. If it's wet today, it'll be wet tomorrow. Now, there's no science involved in that at all. But in Sydney, where you have around about 60 rain events a year, which is a day or a series of days on which it rains, you're going to be wrong the 60 days it starts raining, wrong the 60 days it stops raining. That's 120 days wrong. The other 245 you're going to be right. So that gives you an accuracy rate of about 67%. So once the accuracy of the forecast drops below that level, there's no point in issuing a forecast because you might as well just go with persistence.
The area turning 001 in southeastern corner.
Once the analysis and computer prognoses have been done, the forecasters have a chart discussion. They look at the different models and they come to a consensus agreement as to the likely pattern of the weather over the next 7 days. Then, based on the chart discussion, the forecast policy is issued. This is the basis from which all forecasts are issued. This makes sure that the people doing aviation forecasting aren't forecasting one thing, while the people doing public weather forecasting are forecasting another.
Probably temperatures getting up to around 14.
Forecasts are issued throughout the day.
I think probably, particularly places along the slopes, we'll get another 10 to 20 millimetres during Thursday, Friday.
Within the forecasting centre, there is the aviation section, the public weather section and the severe weather section. Aviation looks after the forecasts for aeroplanes. The public weather forecaster looks after country and city forecasts, wind, temperature predictions and warnings. The severe weather team forecasts tropical cyclones, severe thunderstorms and fire weather. Within the bushfire season, special attention is given to forecasting weather conducive to the spread of bushfires.
As well as doing an isobaric analysis of the charts, that's looking at the pressures, you can do an isothermal analysis which looks at temperatures. You can look at the humidity.
If the severe weather team is expecting wind speeds above a certain level, combined with high temperatures and low humidities, they may issue a fire weather warning. If there is an extreme fire danger forecast, they then send this information out to the fire services and the relevant authority issues fire bans. Should fires break out, the severe weather team comes into action. The movement of fires is largely determined by the movement of air, in particular low pressure systems. By forecasting the temperature and wind speeds, forecasters assist the firefighting services in predicting how the fire will behave and spread. Weather forecasting is a vital service. It helps us to plan ahead on an everyday basis, but it can also save lives.